Welcome everyone to this first session by Scholarden on GRE quant preparation. Today we're going to be discussing coordinate geometry and graphing functions. So during this, we're going to first of all understand the axes in the Cartesian plane. We're just going to look at how to plot points on the Cartesian plane or 2D axis. We're just going to then talk about the different features of lines, straight lines, for example, the intercepts, the slopes, and then we're going to look at various forms of the equations. So at any time, if you have any question, you can leave it in the chat, and I'll try to answer that before our session ends. Right, let's begin. Okay, so first of all, why coordinate axes? So the first thing is that this is a very effective way of representing numbers graphically. So we are familiar with, for example, the number line. Sorry about that. Okay. The number line shows, for example, numbers in a straight axis. So over here, what we can do is we can show various numbers along the line. So let's see, these couple of notches represent the numbers. So this could be anything. So these arrows represent that the numbers extend to both sides, both on the positive and the negative axis. So let's call this number as 0. So 1, 2, and 3. And this is going to be -1. So these numbers are going to extend towards the positive side on the right and the negative side on the left, right? So this is one aspect of, representing the numbers graphically. However, once we go to the coordinate plane, over there we have two different axes. So both of these axes are shown like this. So this is what a typical coordinate plane is like. So over here, the horizontal axis is called the x-axis, and this one over here is called the y-axis. As always, the right side, this extension, this contains the positive values for the x-axis, and this axis towards the upside represents the positive values for the y-axis. So similarly, going towards the left along the x-axis, these are all your negative values, and going towards the down on the y-axis, these are all the negative values for the y-axis. So now what happens is these two axes have the same sort of structure like that of a number line. The only thing is that these are perpendicular to each other. So these are always at 90 degrees to each other. So you can have various values shown across these axes. And this is just for representational purposes. We are going to do different exercises as well. So just hold on. Let me let the others participants enter as well. Okay. Right. So continuing on. So what happens over here is that we've got all these values, the positive values along the right side going towards the right, and the positive values along the y-axis going upwards. The negative values going to the left along the x-axis, and the negative values going downward along the y-axis. So this point over here, this right here, the intersection, this is the point 0, 0. And this is often called as the origin. So this is the origin. So this is the point of intersection of the x and y axes is called the origin. So let me just quickly redo this again. Okay. All right. So this was our x-axis. Okay. So the important thing about this is that, first of all, this axis, we can see that this intersection of these two axes, this is called the Cartesian plane with two axes, the x-axis and the y-axis. And we see that there are 4 different sections that are made by this intersection. So this is one section, this is section 2, 3, and 4. These are called as the quadrants. So in mathematical convention, this is called the first quadrant. And we go counterclockwise, and this is called the second quadrant. Moving downwards, this is called the third quadrant, and this is called the fourth quadrant. Why these are important is because when we are plotting any number on the Cartesian plane, it helps to understand where that number lies within the quadrants. So for example, we've already seen, or as I've mentioned earlier, going towards the right, so you've got the positive values for the x-axis. And going upwards along the y-axis over here, you've got the positive values for y. Again, there's a few more, okay? Right. So any value lying in the first quadrant is going to have both of the values for both the x and the y-axis as positive, because it is going to be shown somewhere over here in this region over here. So any value or any point that is plotted in this section of the graph is going to have both of the values as positive. Conversely, if something was to be plotted over here in this part of the graph, let's say over here, so this is going to have different characteristics than quadrant one. So in quadrant one, we had positive values for the x, but over here we can see that this quadrant lies along the left side of the x-axis, the left side of the origin. So what is going to be the characteristics of these points in the second quadrant is that they're going to have negative values for the x-axis or negative x coordinates and positive y coordinates. So along this axis, you're still going to have positive values, and over here you're going to have negative values. We're going to see how to plot the values shortly, but I just want to reinforce what is the significance of these quadrants over here. So over here, you've got the third quadrant, and if we look at the third quadrant, now we've got the negative x-axis and the negative y-axis. So any point that is plotted in this quadrant is going to have negative values for both the x and the y-axis. And if we look at the fourth quadrant over here, so it's going to have, let's say, negative values for the y-axis, but positive values along the x-axis because it lies along the right side of the positive of the x-axis from the origin. So anything that is lying in the fourth quadrant is going to have positive values along the x and negative values along the y. So a quick question, given this scenario that we've got these four quadrants. So if we were to plot a point, let's say 1 and 5, where would that lie? So you can solve it if you've got any resources in front of you, or you can solve it in your head, and I'll try to do that in front of you. So we see that anything that has to be represented on this coordinate plane is supposed to follow this convention. So first, we're going to write the x value, the value of the x along the x-axis, and then we're going to write the value along the y-axis. So the point that we are looking at is 1 and 5. So along the x-axis, its value is 1, and along the y-axis, its value is 5. So now we see that both the values along the x is positive and y is positive. So this is going to lie in the first quadrant. We're not really concerned with, for example, where it lies exactly. The question was, in which quadrant does it lie? So this value, because both of the x and the y coordinates, the x coordinate in this case is 1, the y coordinate in this case is 5. So the coordinates of the points 1, 5 are going to lie somewhere over here in the first quadrant. So if similarly, it was something like this. So for example, let's call another point B, and let's call it -2 and -3. So where would point B lie? Just in terms of quadrants, where would that lie? So we have to see that the x, the value of the x coordinate over here, that's -2. So it has to lie along the left side or the negative x-axis over here. And then the y coordinate is also negative. So it has to lie on below the origin along the downward axis of y. So it's also negative. So over here, we can see that both the x and the y coordinates are negative. And so they must lie in the third quadrant over here. Sorry about that. All right. Okay, omitted them all. Okay, so continuing back with our lecture. So this is the importance or the significance of the quadrants, that when you're looking at any point, if you're looking to plot any point, what you can do is let me just bring up the chat as well if there is anybody who has sent a message. So the quadrants are important in this respect, that if you're given a point, you can actually see which quadrants the points lie on. Okay, moving on. Okay, so here's another exercise. We're supposed to plot 3 points. So the first point is point A, which has the coordinates 2 and 3. Again, the convention is that the first value always belongs to the x-axis, and the second value belongs to the y-axis. So this is with this convention, with this convention, what we're going to do is we're going to write the convention over here so that we remember this. So x and y. So the first value is always belonging to the x-axis. The second value belongs to the y-axis. So over here, we see that the value along the x-axis is 2. And the value along the y-axis, is 3. So let's say this is 2. This is 2 over here. And this is 3 over here. So this is 3. So the point A actually lies where the value of y is 3 and the value of x is 2. So if we start moving along the x-axis, along this x is equal to 2, we start going upwards where we meet the y is equal to 3 notch. So this is where point A lies, because over here, the value of x is 2 and the value of y is 3. So this point over here is your point A. Let's look at point B. So point B is minus 3 and 4. So first of all, we realize that the value of the x coordinate over here is negative. So minus 3 and 4. So this is for the x-axis and this is for the y-axis. Looking at it, this is negative for the x and positive for y. So quadrant 2. Let's shift to quadrant 2 over here. So if you go to quadrant 2, okay. So if we go to quadrant 2 over here, let's look at this. So this is minus 3. So this is, first of all, let's start with x is equal to minus 3. Okay, so this is this point over here. That is x is equal to minus 3. And then we start going upward because the value of y is positive, and we find out where we're going to find the value of y is equal to 4. So along this line where we find the value of x is equal to 3, we start going upward. So this is y1, y is equal to 2, y is equal to 3, and y is equal to 4. So over here, at this point over here, this is your B. So minus 3 and 4 at this point over here, this right here. Let's look at the example of C is equal to minus 2 and minus 1. So this again tells us something. Both the x coordinates and the y coordinates are negative. So this is going to lie in the third quadrant. Again, because y, going from the earlier slide, the first quadrant, both x and y are positive. Second quadrant, x is negative, y is positive. Third quadrant, both the x and y axes are negative, so the corresponding coordinates are also going to be negative. And in the fourth quadrant, we have x is positive, but the y is negative. Okay, right. So, okay, so C has both these coordinates as negative. X is equal to negative 2 and y is equal to negative 1. So first of all, we go and find out where x is equal to minus 2 is. So over here, this is x is equal to minus 2. And then we find out where y is equal to minus 1 is. So this is y is equal to minus 1. And we find out where we satisfy both of these conditions. So x is equal to 2, we start moving along this line. And we find out this is the point where we reach in line with y is equal to minus 1. Okay, so this is point C over here. We could do it in a reverse order as well. We could first find out where y is equal to minus 1 and then move to find out the exact coordinate along the x-axis as well. In both cases, you're going to end up at the same point. So, for example, let's say we try to plot C in this manner. So C is minus 2, minus 1. So let's say, first of all, we identify the y coordinate, which is minus 1 over here. We find out y is equal to minus 1. And then we traverse along the negative x-axis because we are supposed to find out the negative value of x. We traverse along the negative x-axis and we reach over here. And this is where we find out that y is this x is equal to -2. So again, this is the same point. So the order does not matter as long as you know which axis to traverse along. Okay, so the plotting is important because at times in GRE, what you're given is you're given a series of points and you're asked to plot the points, generate a line, and then find out the equations of the line. So we're going to look at the equations of the line later, but why this basic is important, this basic concept of plotting the points on a Cartesian plane, this x and y axis is important, is because you can face questions in both ways. You might be given a graph. A line is a simple graph. So a graph is anything that can be represented pictorially and that has some mathematical expression that is governing it. So you could be given a line, or you could be given points, and you were required to plot those points on the x and y axis. And then you're supposed to draw a line and you're supposed to answer different questions. Or you might be given lines or a line on the x and y axis, and you're asked different questions. So for example, if a certain point lies on that line, or if, for example, what are certain characteristics of that line? So we're going to look at those characteristics in a bit later. But I hope that the first aspect of the Cartesian coordinates, which is this x and y plane, so the nature of the quadrants 1, 2, 3, 4, and how do we plot points on these x and y axes is clear to you. As I said earlier, if you have any questions, you can always leave a question in the chat and I will be sure to answer that before the session ends. Okay, moving on. So now we've seen how the plotting the points on an x and y axis work. Let's look at the line and the equations. So first of all, context matters. So if I have a number line, okay, there are different notches. Okay, let me just label them as well. So let's say this is 0, 1, 2, and 3. And along the left of this 0 or the origin are the negative values, so -1 and -2. Quick question for you to ponder upon. Just think about it. If I were to say that there is a point x, okay, so let's call it x. X is equal to 2. So how do we plot it on this number line? Okay, let me just give you a quick pause, 3 to 5 seconds. So we are supposed to plot point x is equal to 2. So this is going to be somewhere over here. So this point, this is going to be on the number line. This is going to be x is equal to 2 because this is where the value of x is 2, or the point is 2 because we are given only one value. So this is where this value can be found. Okay, right. So, but what happens, let's say, if we were to plot the same thing on the Cartesian plane? Let's say, again, the question is x is equal to 2. And what do we do about that? How do we plot that on a Cartesian plane? Again, take 5 to 10 seconds, quickly ponder upon these things, and then I'll continue. Okay, so this is 1, 2, 3, 4, and 5. Okay, positive values for the x-axis and positive values for the y-axis. Okay, so we were supposed to plot point x is equal to 2. Now we know that this is the x-axis, right? So the first thought from some of you might be that this is x is equal to 2. And this is partially correct. Yet this is x is equal to 2, but this is incomplete. Why? Because if we go along this value of the x-axis and we start moving upward along the x-axis, let's say over here, this is also x is equal to 2 because this is in line over here. This point is also x is equal to 2. This is also x is equal to 2, and this is also x equals 2. So if we start going upward along this point on the x-axis, all of these values are x is equal to 2. The same is the case if we start moving downwards. This value is also x is equal to 2 because this is in line with the value or the x coordinate 2 over here again. And all of these points lie along x is equal to 2. So what's the purpose of showing this? The purpose of showing you this is that now we have got a collection of points. We've got a collection of points which all satisfy this particular condition. That for all of these points, we find that the x coordinate is 2. We're not really concerned with the y coordinate right now, but what we can see is that the x coordinate for all of these points is 2. So again, what happens is we can actually extend it. We can, connect all of these points. And what does this become? So this is a line. So in mathematical terms, what is a line is a locus or collection of points which follow certain mathematical relationship. So over here, the relationship is this is a line, this particular line over here. I'm going to point the arrows because just to indicate that this is the line that extends upwards and downwards both ways, doesn't end. So this line satisfies this condition that along this line or all the points which are part of this collection, this satisfy this value that for all these coordinates, all of these points, let's say all of these, the x coordinate remains 2. The y coordinate might change, but the x coordinate remains 2. Okay, so this is one of the basic, very, very, let's say, simple or straightforward examples of a line, is that this is a collection of all the points which satisfy this value that, for example, for this x is equal to 2 is satisfied. So all of the points along this line satisfy this. So a coordinate over here, sorry about that. Let me just quickly erase it. Okay. So a coordinate along this line might have different values for y. So for example, let's say if this is 5 along the y-axis, so over here, the point would be, if there's any point, so this is going to be 2 and 5. Why this is going to be 2 and 5 is because we are moving along x is equal to 2, but along y, this is 5. So this point is going to lie on this line, y, because the value of x remains 2. So all the points for which y is equal to 2, x is equal to 2 is satisfied lie along this line, okay? So let me just quickly bring up another example. So let's say that I would want to draw y is equal to 3. Sorry about that. Let's quickly erase it. Okay, so y is equal to 3. I want to write y is equal to 3. Let's say y is equal to 3 lies somewhere over here. And so what is going to happen with y is equal to 3? So y is equal to 3 is going to be the collection of all the points for which y coordinate is 3. So we don't want the y to change. So what we're going to do is we're going to start moving parallel to the x-axis where y is equal to 3. So over here, y is equal to 3, over here again, and we keep on plotting points along y is equal to 3 towards the positive x-axis, but it is also going to hold true towards the negative x-axis. So over here, all of these points along the x-axis for which y is equal to 3, again, satisfy this condition. So they're going to become a straight line. And this line has y is equal to 3. So this is, let me write it neatly again. So this is the line for which y is equal to 3. And if we look at any of the points that are part of this line or lie on this line, to be more accurate, for all of them, the y coordinate is going to remain 3. The x coordinates are going to change as we move either to the left or to the right. So the x coordinates might change, but the y coordinates are going to remain the same. Okay, so this is again a line for y is equal to 3. So we understand how things changed from a number line to the Cartesian plane. On a number line, this was a point. When we entered the Cartesian plane, this particular value became a line. Okay, so let me just quickly give you another example. All right, okay, so this is, sorry. All right, okay. So, okay, here we had the Cartesian plane, and we said that we had a line x is equal to 2, right? So let's call this that this is your x-axis, this is your x-axis, this is your y-axis. So this is your point 2. Okay, I'm going to write 1, and this is your origin. The reference point is 0 and 0. Okay, right. Okay, so this is x is equal to 2. This was the first line that we drew, x is equal to 2. So a quick question for you. If there was another line, this time may be different, okay? But it passes through x is equal to 2, but in a different direction. Let's say this line over here. Is this also the line that satisfies x is equal to 2? This is a quick question for you to ponder upon, okay? Just take 10, 15 seconds, think about this, that whether this line, which also passes through this coordinate, x is equal to 2, is this line also x is equal to 2? Can we represent this line as x is equal to 2? All right, so that's not true. So this line over here is not x is equal to 2. Why? Because it does pass this point over here, this x is equal to 2 over here. But if you see at this point is going to have an x coordinate which is going to be different than 2. Okay, so this might be 3 or 5 depending upon, for example, the scale, and this point might be, for example, 4 or 6 something. Okay, so this is not x is equal to 2 line. So what this tells us, this is important, is that these lines, for example, they are passing through this point, x is equal to 2, this coordinate on the x-axis, which is x is equal to 2, but these both lines are not the same. So this is probably some of the a major mistake that some people tend to make, that because one point lies on a line, it might be belonging to the same mathematical expression over here, so it might be the same as x is equal to 2. That's not the case. What this also tells us, that if we look at this, there could be another line, for example, that passes through this point. There could be another line that passes through this point. So there could be infinite number of lines that pass through a single point, but they could all be different lines, okay? But there is only one line that is x is equal to 2, which is this straight line, okay? So this is, for example, important. Another important thing that just let me quickly highlight is that, for example, if we have got a line at x is equal to -3, so this line, if we again plot, so this is going to be at x is equal to -3, and this is going to be, let's say, over here. And you can see one characteristic which relates it to the y-axis, which is the axis over here, is that x is equal to -3 line, or any line that is drawn with a singular value or the single value of x only, is parallel to the y-axis. So this keeps on going upward and downward along the y-axis. Okay, so this is parallel to the y-axis. Conversely, if you had a line governed by, say, y is equal to -5, let's say y is equal to -5 is somewhere over here. Okay. Okay. Right. Okay. So y is equal to -5 is somewhere over here, right? Okay. So conversely, what we can see is that this line is going to be over here, drawn like this. So all of the collection of all the points that are, say, which have the y coordinates as -5, different x coordinates, but y coordinates is -5. So what we see over here is that this line is drawn parallel to the y-axis. So this is interesting. Any line which only specifies the y value is drawn parallel to the y-axis, parallel to the x-axis, and any line which is drawn by with a specific x, the value of x is always drawn parallel to the y-axis. So, for example, this is important. Why? Because this helps in a lot of different things. These are small little things that the knowledge of which is greatly helpful during the GRE exam. Why? Because the GRE exam is ultimately going to test you in a time compressed environment. So an understanding or information about these things helps you greatly. So just a quick recap: any line which, for example, is drawn with the given x-axis or with the value of x is drawn parallel to the y-axis. So this is the case for y, so x is equal to -3, this line. And any line which is drawn for a given value of y, for example, in this case, y is equal to -5, this is drawn, for example, parallel to the x-axis. So a single line which only specifies y coordinate is drawn parallel to the x-axis, and any line which is drawn with a single x coordinate is drawn parallel to the y-axis. Okay, I hope this is clear, and I hope that so far there are no questions. Quick question for you. If I were to ask you how to specify this y-axis, what would be your answer? So if I ask you, give me the mathematical expression that governs the y-axis, this axis over here, what would be, so for example, that mathematical expression? And conversely, if I were to ask you, what is the mathematical expression for the x-axis, what would be that? So just take 5 to 10 seconds, quickly think about this, maybe you write your answers so that when I tell you the answer, you can, check it against you. Yeah, so one of the participants, says y is equal to mx plus c. Yes, that is the general equation of the line. Any line, any straight line in the xy plane can be drawn if we change the values of m and c. We're going to look at that form of the equation. But what my question pertains to is in this form. You see, we had this line x is equal to -3, we had this line y is equal to -5, and now I'm asking you to come up with an expression for the x-axis and the y-axis. So you're free to share your answers in the chat. This is going to help us, for example, exchange ideas and know if there is any sort of question or if there is anything that I need to repeat. Okay, so look at this line, this y-axis over here. Where does it cross? It crosses at x is equal to 0, right? We said any line which is drawn with a given with a single value of x is always parallel for me, right? So if anybody's screen is stuck, you can rejoin and I'll okay, right? Okay, you've got a couple of complaints. Let me just quickly reshare my screen. Let me just pause sharing, okay, and then I'm going to resume sharing. All right, let me just quickly draw. So this is the x-axis. If you can see the screen now, I've just drawn an arrow along, somewhere over here. So this is your x-axis, and we saw that earlier. Any line which is drawn with a given value for the x is drawn parallel to the y-axis. So this y-axis, this guy over here, is parallel to itself, okay? And this is lying at x is equal to 0. Why? Because if we go along this axis, either up or down, the value of x remains 0. Can anybody share if the screen is still stuck? If the screen is still stuck, I'll, for example, pause sharing or restart. Okay, thank you very much. Okay, so now, okay, coming back to our question. The y-axis, the mathematical expression for the y-axis. So if we go along this y-axis, the value of x remains 0. So the mathematical expression that governs the y-axis is x equal to 0, because this is parallel to y-axis, and this, along this line, when you're moving along the x-axis, exactly. So all the values of x are 0. Correspondingly, if we were to look at the x-axis in the same manner, moving along this x-axis, the value of y is going to be 0, right? So this is the mathematical expression which is associated with the y-axis. X is equal to 0. So this is a line at x is equal to 0, and this is the line, this x-axis for which y is equal to 0. So y is equal to 0 is the x-axis line, and x is equal to 0 is the y-axis line. As I said, over here, if we see again x is equal to -3, this line is parallel to the y-axis. Y is equal to -5. This is the line that is parallel to the x-axis. So the x-axis, x is equal to 0. The y-axis, x is equal to 0. So this is your y-axis, x is equal to 0. The x-axis, y is equal to 0. Okay, because when we move along these lines, this is satisfied. If we move along this line, the y-axis, this is satisfied. So I hope that this aspect is clear. And why this is important is because once we are plotting the points, and we're going to look at the concept of x and y intercepts moving forward, so this is going to come in handy, right? So now let's take a look at two lines, right? Let's take a look at a few things over here. So the first line is this particular line, this y is equal to x line. Okay, so y is equal to x. So we are supposed to plot a line y is equal to x. So this is the line y is equal to x. So first, let's not concern ourselves with the second line. Let's first just look at y is equal to x. So for this, what we do is, the simplest thing is, in the chat, yes, any line. One of our friends has said that x is equal to c for y-axis and y is equal to c for the x-axis. For this is x is equal to c is going to be a line which is parallel to the y-axis. X is equal to 0 is going to be the y-axis itself, and x is equal to c is going to be any other line which is parallel to the y-axis. So for example, c could be any value, 1, 2, 3, 4, or -1, 2, 3, 4. So that could change, but the specific y-axis lies at x is equal to 0. And similarly, the specific x-axis lies at y is equal to 0. But any line parallel to these axes, yes, the expression x is equal to c and y is equal to c holds. Okay. Right. So I hope that clarifies it for you. Right. So we are looking at this line y. This is line L1, which is y is equal to x. So let's just quickly plot. We don't want to get ahead of ourselves. So let's just start by plotting the points. So the expression of the line is y is equal to x, right? Okay. So what this means is that this is a line, or this is going to be a collection of coordinates for which x coordinate is always going to be equal to the y coordinate. So if x is 0, y is also going to be 0. If x is, say, 1, y is also going to be 1. If x is if x is 2, y is 2, so on and so forth. And let's just quickly look at the negative side as well. So if x is -1, y is also going to be -1. Same is the case if x is equal to -2, y is going to be equal to -2. So what we shall do is we shall start plotting these points. Let's plot these 4 points, these 5 points that we've just said. So the first point is the point, this coordinate, x, 0, and y, 0. These are all coordinates. These could all be written as 0, 0, 1, 1, 2, 2, -1, -1, and -2, -2. Because this is a value for y, this is a value for x. So you can write them as coordinates as well. So let's plot these coordinates on the Cartesian plane. Okay, so the first point is, say, x is equal to 0 and y is equal to 0. So at this point, this is the origin, and this is the point for which x is equal to 0 and y is equal to 0. Yeah, I am exactly doing y is equal to x. So I hope that answers your question. So this is the first point. So this point over here. Okay, so we have plotted this point. The next point is this point, 1 and 1, for which y is also 1 and x is equal to 1. So first of all, we see again, this is the x-axis. So the value of 1 along the x-axis lies over here. We start moving upward. And this is the point where we see that the value of y is 1. So this is, I'm sorry. Okay. Right. Sorry about that. Let me quickly do that. Okay. Y and x 0, 0, 1, 1. 2, 2, 3, 3. Okay, a different set of coordinates, but the philosophy remains the same. So this was 0 and 0. Okay, so this is over here is 1 and 1. Okay, because this is the point where the value of x is 1 and the value of y is also 1. So 2 and 2. So we go along here. This is x equal to 2 over here. And then we start moving upwards. And this is where we find y is 2. So plotted 3 points. Okay, let's also extend it to the negative side. So any line, okay, any line extends both ways. Okay, so we can do that. We can plot 3, 3, or let's just try something on the negative side as well. So let's say it's going to be -1 for the x-axis and -1 for the y-axis. So over here, -1 along the x-axis, over here, we start coming downward because we're supposed to find out the negative y is equal to 1. And this comes over here. So so we have plotted these lines. And now, if we start connecting these points along the straight line, okay, we connect these along the straight line, okay, and we extend it over here. So this is your y is equal to x line. And what is significant about this line is any point on this line, if you take any point, let's say over here, you take any point over here, the value of the x coordinate and the y coordinate is always going to be the same. This is an important characteristic for y is equal to x, because this tells us that along this is a collection of points. This line, again, as I said earlier, is a locus or a collection of points. And this collection of points has one key characteristic. All the coordinates are the same. So the x coordinate and the y coordinate is the same. So the value for the x coordinate and the y coordinate for any point that is supposed to lie on this line is always going to be the same. So you could extend it to, let's say, positive infinity. You could extend it over here to negative infinity. And for every point that you find on this line, that's going to have the same value for the x and the y coordinate. So for example, over here, this is going to be a part of this line because the x and the y coordinates are the same. Over here, if we extend it, further along the first quadrant, the value for the x and y coordinates is going to remain the same. Okay, so this is a y is equal to x line. Every point that lies on this line has the same x and y coordinates, the same value of the x coordinate and the same value for the y coordinates. I hope that clarifies it. If there are any questions, I'm looking at the chat as well, so I can answer on the go. Okay. Right. Okay. With that out of the way, let's look at a different line. Okay, which is the second line, y is equal to x minus 4. So this is slightly different. Okay, so y is equal to x we had seen earlier, but now this has something else as well. So y is equal to x minus 4. So let's just quickly plot this first. Let's write x over here, the value of y is over here. Okay, so for example, if we say that the value of x is equal to 0, and if we plug in this value, I'm just going to write the equation of the line over here again for clarity's sake. So what is going to be the value of y if the value of x is 0? We plug in the value of, for example, x is equal to 0 in this equation. So over here, if we plug in 0, so y would be 0 minus 4. This is going to be minus 4. Okay, this is going to be minus 4. If we take x is equal to 1, we plug in 1 over here. So 1 minus 4, so this is going to be minus 3. So the value of y is going to be minus 3. If we keep on going forward, so let's take another value. X is equal to 2. We plug in the value of 2 over here in this equation instead of the x. We literally plug in. So we say 2, and we solve this expression. 2 minus 4 minus 2. So the value of y is minus 2. You see where I'm going with this? So in order, if you don't know, the line, what the simplest manner to plot it on the Cartesian plane is just to figure out a couple of points. Okay. An important thing over here. I'm not going to go into the details of that, but only one line can pass through 2 points. If you want to draw a line through 2 points, there's going to be only one line that can pass through 2 points. As I said, as we saw earlier, from across a single point, across a single coordinate, we could draw infinite number of lines. But if we want a line or 2 points to lie on the same line, only one line can be drawn across that. So with this, why is this important? Is because we don't need to plot too many points. Yes, for example, for graphical illustration purposes, we can do that. But if we are drawing accurately, if you're drawing to scale and we're drawing accurately, 2 points are enough, and we can draw a straight line that connects those 2 points together. So let's say we've got the first coordinates, which is 0 and minus 4. Let me just quickly write over here, 0 and minus 4. The second coordinate is 1 and minus 3. And the third coordinate is 2 and minus 2. Okay. So let's just quickly plot them on the x and y, this Cartesian plane. So 0 and minus 4. So where's this going to lie? This is going to lie along x is equal to 0. And where is x is equal to 0? Is this origin. And now we are supposed to find out y is equal to minus 4. So somewhere over here, it's not shown on the graph, but let's say if we extend it, let's say this is y is equal to minus 4. So this point is 0 minus 4. Okay. And then the next point, the next coordinate is 1 and minus 3. Okay. So first of all, we find out where is the x-axis, the value of x is equal to 1. So this comes over here. And then we go minus 3. We start going downward. So this is minus 1 for y, minus 2 for y, and minus 3 for y. So this is over here is 1 and minus 3. So this is this point over here. And the third point is 2 and minus 2. So this guy over here. So x is equal to 2. We start moving downwards to find out y is equal to minus 2. And this point right over here. So this is the point. Now, if we draw a straight line that connects all the 3 points, I am very sorry about that. Very bad drawing on my part. Okay. But again, if we draw a straight line that connects these 3 points, okay, this is the line for which the equation is y is equal to x minus 4. Okay. So this is a line that is y is equal to x minus 4. Okay. I hope that the process through which I've drawn this line is clear. Very simply, first of all, come up with a couple of coordinates, plot them on the x and y axis, okay, and then connect them through a straight line, and this is going to show you the line. So this is the line for y is equal to x minus 4. Any questions or anything that you want to ask? Feel free to leave it in the chat. Okay, so let's move on. Okay, we've seen how to plot lines, so we now understand how we can plot straight lines. So that's these expressions. If I were to right. So we're going to have another session tomorrow, but that's going to be for the students who have signed up for the for the scholarship. Sorry, the scholar and paid membership, because on that we provide access to a number of different questions on the platform which are pertaining to this particular topic, as well as the lessons as well. So, and we are going to cover some of the questions in the next session, which is going to be tomorrow. Okay, so in that case, definitely, yes, we're going to have a session tomorrow for the members who are part of the paid group, and we'll go over some practice questions. And what I can do is I can refer you to some of the material that we have on the Scholarly website, and you can use those to practice these. Okay. Yes, there is going to be a lecture planned tomorrow as well, but that is only for the students that have, that have joined the paid version of the Scholar. So this is a free version, kind of like to give you an idea of what the platform offers. And tomorrow we're going to hold a separate, a different lecture for all our paid members. Okay. Yes, today's topic is line. Yeah. Okay. So, right. So continuing. So for example, if I were to give you a line, say L is equal to, for example, the time is going to be conveyed to you through an email. So if you want to, for example, join, you can go visit the platform page, or you can send a query to ask@scholarden.com, and I'll make sure that our team or one of the member gets back to you. Okay. Right. So if for example, if you had a line 2x plus 3, how would you plot that? So it's again, the process is the same. What you're going to do is you're going to start with some values of x. Okay. You're going to start with, I have to write y is equal to 2x plus 3. So you're going to start with some value of x, to plug in the value of x and find out what is the corresponding value of y. So let's just quickly do the activity for y is equal to 2x plus 3. Okay. Y is equal to 2x plus 3. Okay. All right. Okay. So y is equal to 2x plus 3. Right. Okay. So this is x and this is y. So we are trying to find out the value for y is equal to 2x plus 3. So first of all, let's see, 0. So if we plug in the value of 0 over here in this equation, what do we get? So 2 times 0 is 0, plus 3 is 3. So the value of y is 3. Okay. Next, 1. Okay. I'm not doing the negative values just for simplicity's sake, but you can do the negative values just as fine as the positive values. Okay. So 2 times 1. So we plug in this value over here. 2 times 1 is 2, plus 3 is 5. So you get 5 over here. Okay. And in a similar fashion, what you get is, for example, if we were to plug in the value of 2, say this is 2 times 2 plus 3 is 7. Now you've got these coordinates. So the first coordinate is 0 and 3. The second coordinate is 1 and 5. Okay, the second coordinate is 1 and 5. And the third coordinate is 2 and 7. So if we plot these coordinates on the x and y axis and draw a line that connects these 3 coordinates, 2 should be enough, 3 just in case. Okay, if we draw a line that connects these 3 coordinates together, we're going to have the line which is governed by this equation, y is equal to 2x plus 3. Okay, so practice this on your own time. Just come up with a very simple expression: 2x plus 3, x minus 5, x plus 5. Start plotting the points and see where the plot takes you. Okay. Right. Okay. Okay. So what is the slope? Okay. This is, for example, probably the last thing that we're going to cover today. Let's see what happens. Okay. So what is the slope? We were looking at the Cartesian plane. Okay. And we look at the line. Okay. Any line. Okay, it could be y is equal to x. It could be any line. We don't know the expression of this line. That's not important right now. But what is the slope? Okay, the basic idea behind the slope is that how much a line rises over how much it runs. So the key phrase is rise over run. Okay, so remember this: the slope is rise to run. Yep. Mathematically, what you do is you actually, divide the rise by the run. So I would prefer rise over run than rise to run. So that's, you know, if you're comfortable with rise to run, that works for you. Just don't mix rise and run. So it's not run to rise. Just always make sure that the rise comes first and then the run. Okay. So rise. Let's just stick with rise over run. Okay. Yeah. Thank you. So rise over run. So how much the line rises. Okay. How much the line rises over how much it has run. Okay. So why is this? Let's just take a look at another example. Same line. Okay. Over here, let's take this line. So in this particular case, the rise is actually going downward. So it's actually falling, but the word remains the same. It's we are going to calculate the rise. Okay. So this thing, so how much it changes the rise, which is this axis. The rise is calculated along the y-axis, okay, because this is the vertical axis. So how much it rises, how much it changes along the y-axis corresponding to how much it changes along the x-axis, okay? So this is the gist of it. If we were to calculate the slope, what we want to find out is that how much a line changes along the x-axis, the y-axis, over or divided by or corresponding to how much it moves along the x-axis. Okay. So quickly, you know, let's just take a simple example that shows us this phenomena of rise over run. Okay, let's just take this line. Okay, sorry about this here. Let's take this line. Okay, and let's just mark a couple of points. Okay, so this is 3. Okay, this is 2, this is 1, and let's call this as 4. Okay, and let's call this as 4 as well, just for simplicity's sake. 3. So these are all the negative signs, -1, and this is your origin, and along the x-axis and the y-axis. So what we want to do is we want to find out the slope. Why we want to find out the slope first is because once we have got the slope, then we can look at the equation of line in different light. Okay, we can look at any linear equation in different. So this is an important characteristic of the line itself. So we want to find out the slope of this line. Okay, we want to find out the slope of this line. Okay, so let's look at the rise. Again, the important thing is we want to find out the rise over run. Okay, so this is important. This tells us that there's a division operation over in a as in a fraction. Okay, so just like a over b, we write this when we are mentioning the fraction. So rise over run. So this is a very good example of how you know we can remember key mathematical concepts. So first of all, we find out the rise, and we take it as a fraction over once we found out the run. So let's take the rise, okay? But we're going to take it over the same measures, okay? So let's say we take 2 points, any 2 points, say this point. We say this is y1, okay? And this point, just talking about the y coordinates over here, okay? So just give me a moment. Chat box. Okay. All right. I've got a few answers in. Yes. No. Yes. Yeah, that's true. So what I've tried to do is I've tried to generalize the answers in the chat. So somebody said the slope was -1. Uh, un Unfortunately, that's not true. Why is that not true? Is because we see that the line is going upward. Okay. Why? Because let me just quickly cover the slope first, and then we're going to see why the slope is positive. Okay. Yeah, thanks. Right. So over here, let's call this as y2, the y coordinate. coordinates. What is the x coordinate for y1? Can somebody answer me in the chat? What is the x coordinate for y1? I hope you're still with me. What is the x coordinate for this line? For this line, what is the x coordinate? Again, sorry. What is the x coordinate that corresponds to this line if y1 is 0? Okay. You're right. This is -4, but I want others to be sure how I have arrived at that. Okay. So we took the first value as y is equal to y1 is 0. Okay. So at this point, actually, I should have drawn y1 not over here, but somewhere along the line. That would have been better. Right. So y1 is actually not here, but y1 is the value of the y coordinate over here. Okay. So this would probably give you a better perspective. So this is y1. So this was y1 because, again, this is y is equal to 0. What is the corresponding x coordinate? So the corresponding x coordinate over here, let's call it, yes, absolutely correct. So x1, again, we're not going to be as a coordinate, yes, this point is -4, 0, but we want to take the x and y values separately. Why? Because we have to calculate the rise separately, and we have to calculate the run separately. So we can take the points and we can, extract the x coordinate and the y coordinate from them as well. But for simplicity's sake, I'm just mentioning them separately. Okay, so for this, the value for this point, y1, this is 0, and the corresponding x coordinate is -4. And for this point, which was y2, we said y2 is 4, and the corresponding x coordinate is 0. Yes, absolutely correct. Wonderful, guys. So this is x is equal to 0, x2 is equal to 0, and x1 is -4. So we have gotten 2 points. So now, how do we find out the rise? The rise is calculated as y2 minus y1. Okay? So how much did the line rise? It went from y1, which is 0, went all the way to y2, which is 4. Okay, so the rise is what point comes later, which is y2, which point comes earlier, y1, and the difference between these 2 points gives us the rise. Okay, so this is the rise, which is y2 minus y1. What is the run? Same principle. We start at this point, which is x1, comes earlier. Our line ran along the x-axis, and during this rise, we cannot, again, the important thing is we cannot be taking the run, arbitrarily. It has to correspond to the rise. So we're going to take the run for the same values for which we have taken the rise, okay? So again, the run, we started at x1, okay? And we went all the way till x2, all right? So what is x1? x1 is -4, okay? And x2, again, so the run is the point that comes in later minus the point that came in first. Okay, so this is your rise and this is your run. Let's calculate the rise and run for this particular case. Okay, what is the rise? The rise was y2 minus y1. What is y2? y2 is 4. And what is y1? y1 is 0. So your rise is 4. Okay, cool. And what is your run? Yeah, so x2 is 0. Why? Because x2 comes over here, corresponding to y2. x2 is 0. And what is x1? x1 is -4. Right? I'm sorry, this seems to be some sort of overlap. Let me just do neatly over here. x2 minus x1. So this is 0 minus -4. Keep the signs, always remember the signs. They could change the entire outcome. And, absolutely correct. Rise, no, rise is 4. Again, you can do a recheck of your answer. we see that the line is going upwards as we go along the x-axis, going. Yeah, okay. If you realize, that's wonderful. Yes, absolutely cool. Absolutely, absolutely wonderful. Rise is 4, and the run is also 0 plus 4 is 4. Okay, so you've calculated both the values. You've calculated rise and you've calculated run. So now the slope and the mathematical variable that is conventionally applied to slope is m. Okay, so m is rise over run. In this case, the rise is 4, the run is 4, and the slope is 1. Yes, absolutely, absolutely true, absolutely true. Okay, so in this way, the point of showing this to you is, if you're given a straight line, and if you're given, it graphically, you can find out the slope by calculating this rise and run. And how do you calculate rise? This is y2 minus y1. How do you calculate run? You calculate this x2 minus x1. And what do? You do the fractional operation. So rise over run is y2 minus y1 over x2 minus x1. And this is the expression of your slope. Okay, so simply stated, in typical mathematical terms, without going into the rise and run thing, the slope for any line could be calculated by this expression. You take 2 points, 2 coordinates along the line, you find out their corresponding x and y coordinates. So if you take a point over here, you call it y2, record an x coordinate and call it x2. If you take a point over here, call it y1. This is point 1. So the y coordinate, if the y coordinate, you refer to it as y1, refer to the x coordinate as correspondingly as x1. And if you take the differences and you subtract, if you take the differences and you divide them, so y2 minus y1 over x2 minus x1, this is giving you the rise. How much this line has risen along the y-axis corresponding to how much this line has ran along the x-axis. So rise over run. Okay, so this is the principle of slope, and slope is at the heart of line. Okay, last thing before we call it off. Okay, we're going to do a negative slope. Okay, let's just do a quickly. Where is my cursor? Okay, over here. Okay, let's do a negative slope. Right. Okay. So the expression is y is equal to minus 2x plus 3. This is a simple expression. Okay. What is this line going to look like? I think I've jumped ahead. This we should have, we should not be looking at, the expression of line, because we haven't really covered that. Let me just quickly remove that. And let me just show you, a negative, the line with the negative slope. Okay, a line with the negative slope. Okay. Right, so if you have a line like this, okay, over here. So what happens is, let's say, this is a line. We see that the value, if we go along this way, because this is your positive x-axis. So again, the principle is rise over run. Okay, so if we take this point, so this is your y1, let's call it x1 and y1. Okay, And we take another point. So this is going to be your point x2 and y2. We're not concerned with the values right now, but I just want to show how the slope can be negative. So what is the rise going to look like? The rise is going to be y2 minus y1. Okay. And the run is going to look like x2 minus x1. Now, just by looking at, sorry, somebody just entered. Okay. If we just, okay. If we just look at the values for y2 and y1, which value is greater? Remember that these are the values along the y-axis. So y1 is somewhere over here. And y2 is somewhere possibly over here. So somewhere over here. So this is your value of y2. So y2, and we know that when we looked at the axes first, we saw that this going upward. This is the values of y increasing. And if you look at this way, this is the values of y decreasing. So over here, we see that our line starts over here, y1, goes over here, y2. So instead of rising, y2 is going to be less than y1. So because it is going to be, might be negative. Okay, hold on. Just let me quickly, for example, right. Okay. Sorry about that. Okay. Coming back to our point. So what we were discussing was that over here, in this case, y1 is going to be more and y2 is going to be less. Why? Because this is if you look at the y-axis, this is higher. Y1 is higher, y2 is lower. So y2 is less and y1 is more. So if we look at this difference over here, y2, this guy is less, y2 is less, the variable y2, and y1 is more. So if we subtract a greater value from a smaller value, this result is going to be negative. It's going to be smaller. So for example, assume any value of y1 which is greater than y2. Let's call it this as 3. Okay, let's just call it this as 3, and let's call this as 1. So 1 minus 3 is going to be minus 2, right? So the point that I want to convey over here is that we see that y2 is less and y1 is more. So once we take this difference, the rise is actually going to come out as negative. Okay, the run is over here. If you look at over here, x1 less, x2 more. Why? Because this comes along the x-axis. This is somewhere over here, and x2 is somewhere over here. So x2 is greater, x2 is less because this is the increasing side of the x-axis. Okay, so the run is going to be greater than 0. Okay, so now we've got a number. Let's call this rise over run. Okay, so sorry about that. One words. Okay, so the rise is less than 0. The run is greater than 0. Okay, and so what happens is that if you look at the nature of the fractions, so over here, any numbers, if they're being multiplied by, if a positive number is being multiplied by a negative number, or similarly in case of division, a negative number is being divided by a positive number, or vice versa, a positive number is being divided by a negative number, the answer is negative. So in this particular case, your slope is going to be less than 0. Your slope is actually going to be negative. Okay, so the point that I wanted to convey through the slide was that slopes are not necessarily positive always. They can be negative as well. So a positive slope, a line with a positive slope goes upwards, okay? Because we see that the values of y are increasing as we traverse along the x-axis. And for a line with a negative slope, it is falling, okay? So as we go along the x-axis, the values of y are decreasing. So any line like this is a line that has a positive slope. Any line like this has a negative slope. So for this line, your slope is less than 0. For this line, your slope is greater than 0. Quick question for you to ponder upon. We've got x-axis, or there is any line parallel to the x-axis. Bad representation of parallel lines, but let me just quickly draw a better line. Okay, so this is, both lines are almost the same. Okay, so assume that these two lines, both of these are parallel to the x-axis. So let's say this line is at, what is going to be the expression for this line? Is it going to be x or y? Answer it for yourself. So this is going to be y is equal to 2.5 maybe, and this is, let's say y is equal to 3.25 something, okay? Both lines. What is the slope for this line? Y is equal to 2.5. Can somebody answer? Quickly think about this. The concept is, again, rise over run. Okay, so this is a line that goes parallel to the x-axis. This is the same line, parallel to the x-axis, and we want to find out the slope of these lines. Okay, what is the slope of this line? Yes, absolutely correct. So this line, why is this slope 0? Because we see that the rise is going to be 0. The values of y are going to stay constant. It's going to be y is equal to 2.5, absolutely correct. So the rise is going to be 0 because y2 would be equal to y1. So if you take the difference, y2 minus y1, it's going to be 0. Okay, so any number divided by 0, the other way, 0 divided by any number, that gives you 0. Okay, so any line that goes parallel to the x-axis, the slope is 0. Correspondingly, let's take this line. This is one line. Let's say this is, again, which line is this going to be? This is going to be x is equal to 2.5. Okay, x is equal to 2.5. Right. Okay. And so what is the slope for this line? If this line, x is equal to 2.5, which is parallel to the y-axis, can somebody give me the answer of what is the slope for this line? Yeah, okay. So for people who might be confused, yes, it's not changing. It is parallel to the other axis. But your guiding principle is always rise over run. Yeah, for those of you who've answered infinity, yes, the answer is correct. Why infinity? Why? Let's say the rise is there, y2, this is y2, this is y1, okay? But the x values, the corresponding x coordinates, x2, okay, and x1, if we look at them, x2 and x1 are the same. So this is x2 and x1 is going to be 0. So if you've got any number, this is divided by 0, the answer is infinite. It's undefined. Yes, because the run is 0. Absolutely correct. Because the run is 0, you're rising. So your rise is going to be positive. okay, because you're moving along this line, your rise is going to be positive, but because the run is 0, it's not changing anything along the x-axis, so the slope is going to be infinite. Okay, and these are the key takeaways for the end of our lesson today, for the end of our session today, which is any line that is parallel to the x-axis, the slope is 0. Parallel to the x-axis, you're not rising, but you're running. Okay, so 0, the rise is 0, and you keep on running, so the slope is 0. Conversely, any line that is parallel to the y-axis, in this case, your rise is positive, but your run is 0. So the slope is infinite, okay? Because your run is 0, you're going through a positive rise, so your slope is infinite again, because any number divided by 0, the result is infinite, undefined, okay? The slope is infinite. Okay, so with this, we come to the end of our first session, and I hope that this was beneficial for you. These are some of the materials that we've covered in our Scholarden, test prep website. You can always go and visit scholarden.com/pricing. And that way you can actually figure out if, for example, if you to join in and join our paid sessions. But I hope that this was beneficial for you. As far as the recording is concerned, yes, we're going to upload that on our official YouTube channel. You can follow that on YouTube. You can subscribe that, and we will keep on for the free sessions. Yes, the free sessions are going to get uploaded on YouTube. The practice questions, yes, there are practice questions on this topic. They're part of the Scholarden GRE practice material. The lessons are there. The practice questions are there. And if you want to join the next session, in which we are going to look at different other topics, x-intercepts, y-intercepts, we're going to look at further particular aspects of graphing functions in coordinate axes. You're going to be doing that tomorrow. No, we're not done with the line topics, because there are a couple of different things that they're still left, particularly the x and y intercepts, the equations, if the form of the line equations, okay, and then one of the most important thing is the regions. If you're given, so there are various things. So how do you find out if a line is parallel to another? How do you find out if a line is perpendicular to another? How do you find out if two are intersecting? How do you find out if a point lies on a line? So these are all the things that are yet to come, but these are advanced topics. Today we wanted to do an introduction to the topic of line of graphing functions, because these are the fundamentals. And tomorrow, for again our paid members, we're going to do the remainder of the topics. But these topics are also covered on the website. You can always visit the website. You can check out different content. You can go through various things, and I hope that will help. I hope that I have been able to cover some of the basics, maybe clear a few confusions. And this session has been helpful. We're going to upload this on YouTube. You can revisit this. And I wish you all the best of luck. And we will okay, so if the lessons, you think there is something missing, you can always leave feedback, and we would be happy to help overcome some of those deficiencies, improve the content, so that you guys have the best learning experience. And I hope that today was fruitful, and I hope that it was worth your time. And I hope that I will see you again in the next session.